Figures 11.31 MouseDetailsFrame.java and 11.32 MouseDetails.java. As in our prior examples, we do have a class that just contains main to launch our application, and we have a class that extends JFrame, which is going to be our customized windowing class for the example. Now, the new stuff that we're going to show you in this example are some of the features that allow you to test for things like mouse clicks and whether it was the left mouse button or the right mouse button or the center mouse button. But in addition, we're going to demonstrate how to use the so-called adapter classes. For each of the event listener interfaces that contains two or more methods that you may need to define, there is typically an adapter class that already implements the interface and provides an empty-bodied version of every method in the interface. That way, you can extend the adapter class and override, say, one of the methods in the interface instead of all of them, so that if you only care about one method out of several, you can just override that one. So that's what we're going to do in this example. First, let me show you the running functionality of this example, which is going to allow us to test various mouse capabilities. So if I use the left mouse button to press the mouse and let go, I can see that I clicked one time with the left mouse button. If I use the right mouse button to do the same thing, I can see that I clicked one time with the right mouse button. And I do have a 3-button mouse, so if I use the center mouse button to click, I can see that I clicked once with the center mouse button as well. So we're going to demonstrate how to distinguish between the different mouse buttons, because sometimes you need to know which mouse button is pressed in order to implement different functionality. Separately, you can see that if I click twice with the left mouse button rapidly, that it now tells me that I clicked 2 times with the left mouse button. In fact, if I keep clicking very rapidly, you can see that the counter keeps incrementing because I'm within the threshold of time between clicks where it will keep incrementing that counter. However, if I now wait for a moment and then click again, you can see that the counter goes back to 1. So even with the right or center mouse buttons, I can get that type of effect. Again, if I click rapidly enough. However, if I click once and wait a little while and then click again, you can see the counter is not changing because I was not within the threshold value. All right, so we're focusing on the different buttons on the mouse and how many clicks there were, but also focusing on the new concept called an adapter class for doing event handling. And you can see here that we've imported the java.awt.event package's mouse adapter class. And what I'd like to do first is take a look at that class before we actually use it in a program. So it's in the java.awt.event package, and it is a class, so we'll find it down here in the classes part of the listing. And for the mouse adapter class, if you take a look at its beginning of its definition, you'll see that it's an abstract class called mouse adapter that extends object, and it actually implements 3 different interfaces: mouse listener, mouse wheel listener, and mouse motion listener. Now, we've already talked about mouse listener, which had 5 methods, and mouse motion listener, which had another 2 methods. Mouse wheel listener is so that you can listen for events from the wheel on many of today's mice, excuse me. And when I click mouse wheel listener as an interface type definition, you can look at its methods and see that there's one additional method there, mouse wheel moved, that you can use to receive the mouse wheel events as well. So we actually have 3 different interfaces that are implemented by class mouse adapter. And as in any other class, when you go to its method listing, it will show you all the different methods that are part of that class. Now, you know from looking at the online doc set previously that if you're looking at a class and the class does not explicitly show the keyword abstract over here on the left side, that this is a concrete method that you happen to be looking at. So all of these are concrete methods that are defined by the class mouse adapter. So you might be wondering, well, wait a second, if those are all concrete methods, why is the class declared abstract? And the answer is because they don't want you to create objects of the mouse adapter class, because all of those concrete methods have empty bodies. They don't do anything. So in order to make this a useful class to extend and use in the code, they want to force you to extend the class, and then they want you to choose which method or methods to override for mouse event handling for the purpose of your application. So this is an example of an abstract class that actually does not contain any abstract methods. So let's go ahead and use that now in our source code. We've got our MouseDetailsFrame class, and we've declared a private string called details, which we'll use to create the string that is displayed in the JLabel called status bar, which will be placed at the bottom of our window. We have a small constructor in this example. We use the super keyword to pass the string mouse clicks and buttons to the superclass JFrame constructor, and that becomes our title bar string. We create a new JLabel called status bar, and we give it the default text click the mouse, and we add the status bar JLabel to the south region of the border layout. Now that's the only region we're using in this window. However, unlike the center region, the south region is not capable of expanding to fill all available space. So the JLabel will simply appear at the bottom of the window, and its height will be the height of the JLabel itself. And then finally, we add to this MouseDetailsFrame a mouse listener, and we give it as an argument a new mouse click handler object, which is an object of our nested private inner class, private nested class. And at line 26 through line 46 is the definition of that class, which extends mouse adapter. So let's think about this for a moment. We're calling add mouse listener, and we're giving it a new mouse click handler as an argument. Well, let's think about what types are associated with mouse click handler. Certainly a mouse click handler is a mouse click handler, that's its class name. A mouse click handler is also a mouse adapter because it's extending mouse adapter. And we just saw that class mouse adapter implements 3 different interfaces: mouse listener, mouse motion listener, and mouse wheel listener. So a mouse click handler is a mouse listener, a mouse click handler is a mouse motion listener, and a mouse click handler is a mouse wheel listener as well. Remember, when you extend a class and that superclass implements interfaces, you inherit all of that superclass's is-a relationships. So going back up to line 22, when we call add mouse listener, we have to give it a mouse listener object, and a mouse click handler, which extends mouse adapter, is therefore also a mouse listener object because mouse adapter implements mouse listener. Now, for our purposes, we only care in this example about the one concept of clicking the mouse. So because of that, we've overridden only the mouse clicked event handler. Now, you have to be very careful when you're using an adapter class, because if you accidentally misspell this method, let's say we call it mouse clicked with a lowercase c, this is a perfectly valid method definition. However, it will never be called because it's not the mouse clicked event handler, it's just another method that happens to be called mouse clicked with a lowercase c. The mouse clicked event handler is required to have a capital C. And when you extend an adapter class, you already inherit a full implementation of the mouse clicked method. So if you misspell it here, you won't get any hint of an error. You simply won't have any functionality in your program, and that may be a very difficult bug to find in your code, a very subtle bug. So you want to be very careful when you're overloading the methods that you inherit from an adapter class to make sure that you spell them correctly and use the proper sets of parameters as well. So when a mouse click event occurs for our JFrame, we're going to call this method, or it's going to call this method. We're going to capture the coordinates where the method occurred, and actually, now that I think about it, we're not even using these in this example, so this can actually be deleted. We're going to create the string that is going to be displayed in our JLabel. We start by creating a formatted string containing clicked some number of times, and then we invoke event.getClickCount, which tells us the exact number of times the mouse was clicked. And then we use other features of the mouse event class to help us determine whether it was a left, right, or center mouse button click that caused the event. Now, if you think about it, different computers have different mice and different numbers of buttons. For example, a typical Macintosh mouse has 1 button, whereas a typical PC mouse nowadays has 2 or 3 buttons, and a typical Linux mouse usually has 3 buttons as well. And for mice that don't have 3 buttons, you can simulate 3 buttons by using a combination of keystrokes and button presses on the mouse. So in a 3-button mouse, the way that you can tell whether or not you've pressed the left, center, or right mouse button is based on whether certain methods of the event object return true. If the event object's isMetaDown function or method returns true, that would indicate a right mouse button click. Now, if the button, or the mouse rather, doesn't have a right mouse button, that would indicate that the meta key on the keyboard was pressed in addition to a different mouse button being clicked on that mouse. For example, on the next part here, if event.isAltDown is true, that would indicate a middle mouse button press. If the button or the mouse does not have a middle mouse button, that would indicate that you're holding the Alt key at the same time as clicking. And if those two are not true, then we would know that it's a left mouse button click that occurred. Or in the case of a Macintosh, the only mouse button that got pressed for a single button mouse. So you can use a combination of keystrokes and mouse clicks to simulate 3-button mice on systems that don't have 3-button mice. And then separately, you can use these methods that check whether certain keys are pressed also to help you determine for 3-button mice which mouse button was pressed in each case. So based on that, we're going to add to the details string with the plus equals operator with the right mouse button, with the center mouse button, or with the left mouse button. And then finally, we're going to set the JLabels text to that details string. And by the way, as soon as you change the text on a JLabel, it immediately updates on the screen as well. So the key thing that we were showing you here is the fact that you don't necessarily have to implement lots and lots of methods from a given interface. If the interface has an adapter class, you can extend the adapter class and override the key method that you're interested in. And then separately, we introduced the getClickCount method to determine how many times a mouse button was pressed, and also the isMetaDown and isAltDown methods, which can help you determine which mouse button was actually pressed. In the concept of key events, isMetaDown and isAltDown and also the isShiftDown method would be used for key events to determine if those keys were actually pressed in combination with other keys on the keyboard.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than Live Lessons, self-paced personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.